In this video, we are going to be solving exponential equations. We're going to start by solving this problem up here, 2 to the x equals 11, and we're going to be using two principles. The principle of logarithmic equality, which essentially says that if we have an equation, so I know the arrow is pointing to one direction, but it should also point the other. So if we have an equation, if x equals y, then the log base a of x equals the log base a of y. Basically, this means that if we have an equation like this, we can just take the log of whatever base we feel like. Log base 2, for example, of 2 to the x equals log base 2 of 11. The reason we want to do this, because it looks like we just made the problem more complicated, the reason we want to do this is this power log rule, which says if we're taking the logarithm of something that has an exponent, that thing can get kicked down in front as a multiplication. So k was an exponent of what we were taking the logarithm of. It turns into k times log base a of that number. What this means for our problem is we can take this exponent of x and kick it down in front. This becomes x times log base 2 of 2 equals log base 2 of 11. And again, I just picked log base 2 because it seemed convenient. It is kind of nice on the left-hand side here because log base 2 of 2 just equals 1. But if we want an approximate answer, we probably should use a logarithm that we can plug into our calculator. So log base 10 or log base e for common log or natural log. Let's go ahead and do that. I want to solve that same problem, and I want to give an exact and an approximate answer. Keep in mind what we just did was an exact answer because log base 2 of 2 is 1. This is x times 1 equals log base 2 of 11. And again, how that logarithm is 1 is we're multiplying 2 a certain number of times to get to the number 2. And that certain number of times is the number 1. So our answer could just be written as log base 2 of 11. Again, this is not very convenient for entering it into our calculator. To solve this, I still need to get the variable out of the exponent, and I'm going to do that by taking the logarithm of both sides. I'm going to go ahead and use log base 10. Log base 10 just looks like the logarithm is missing its base. So this is log base 10 of 2x equals log base 10 of 11. Our exponent can be rewritten as multiplication. X times log base 10 of 2 equals log base 10 of 11. And at this point, we can just divide both sides by log of 2. The log of 11 divided by log of 2 is our exact answer. Or another way of representing this on the previous page was log base 2 of 11. Going back and forth between these two forms is something cool about logarithms that we're not going to be talking about in this class, so don't worry about it. I do want to say that log base 10 of 11 divided by log base 10 of 2, be careful with your order of operations. I don't want to just say, oh, it's the log of 11 divided by 2, because that is a different number. That's a different beast. So keep your logarithms in place. If I was to type this into a calculator to find my approximate answer, do common log 11, close parentheses, divided by common log 2. X is approximately 3.459431619. The homework is not very good about telling us when we should round, but a general rule of thumb when working with logarithms seems that we frequently round to 4 decimal places. 3.4594. Now let's do this problem. This is a little more complicated than the first one because we have a number that's multiplied to the exponential term. Since it's multiplied in, the first thing I want to do is divide it out. The reason I want to do this, I want to isolate this exponential term. That's the only way that I can use that property of logs and bring the exponent down in front. Step number 1, divide both sides by 11. 4 to the 3x plus 5 equals 3. Now, I want to use a logarithm I can plug into my calculator, so I'm going to mix it up and use natural log. Common log would also work, should get you the same exact answer. Once we take the natural logarithm of both sides, we can use that property of logs that takes the exponent, brings it down in front. This turns into 3x plus 5, that whole quantity, times the natural log of 4 equals the natural log of 3. Since the natural log of 4 is multiplied in, that's just a number. I'm going to divide it out. 3x plus 5 equals this ugly thing. And then solve the equation from there. Subtract 5 on both sides. 3x equals natural log of 3 divided by natural log of 4 minus 5. And divide both sides by 3. When I'm dividing by 3, I know that if I just write this as a complex fraction, it looks a little crazy. You might not know how to enter that in. So instead of saying divide by 3, I'm going to say dividing by 3 is the same thing as multiplying by 1/3. And then just distribute that 1/3 through. This becomes x equals natural log of 3 divided by 3 times the natural log of 4 minus 5/3. While that is not pretty, that is the exact answer, and we can go ahead and enter this into our calculator. Be careful with parentheses, so I encourage you to work this problem along with me. I ended up with x equals approximately negative 1.4025 if I round that to 4 decimal places. One last problem. Solve 100 times e to the negative 0.02t plus 6 equals 12. Isolate the exponential term first. So I want to get that e to that power alone. So I see right now it's multiplied by 100 and 6 is added to it. So I want to undo both of those things. I'll start by subtracting 6 on both sides and then divide both sides by 100. E to the negative 0.02t power equals 0.06. At this point, we have our exponential term isolated. To bring down that exponent, I need to take a logarithm of both sides. While you could use common log, I strongly suggest you use natural log. Because whenever the base of the logarithm, like log base 5 of 5 to whatever power, we're taking log base 5 of 5 to the 17th, it equals 17. Think about what you know about the property of logs, and hopefully this will make sense. So the log base 3 of 3 to the 8th just equals 8. This means if we have the base match the number we're taking the logarithm of, just is 1. And so it makes the computations easier. So with that in mind, I'm going to take the natural log of both sides because that's log base e. And then when we take logarithm of some number with an exponent, that exponent comes down in front. That becomes negative 0.02t times the natural log of e equals the natural log of 0.06. The natural log of e, you can type that into your calculator if you don't believe me, but it's the number 1. What we have here is negative 0.02t, the 1 doesn't do anything, times 1 doesn't change, equals the natural log of 0.06. From here, we're almost home free. Just divide both sides by negative 0.02, and t equals whatever that becomes. I got 140.6705, approximately. Thank you.